I am Raushan Kumar. In the 3 classes, I was in contact with you, and today I discuss about the conservation of momentum. So, in the laws of motion, we are discussing to become the best performance in the CBSE, NEET and IIT-JEE Main and Advance. I am also IIT. In the month of December, I finished the entire part of the physics, including the problems of H.C. Burma. You can say also concepts of H.C. Burma book. So this is a body, this is a system. My body, your body, body of a tiffin box. Basically this is a what system? Your house, this classroom, all these are what? A system. So many things are working here, and in this system, particle 1 having mass m1, velocity is v1 in this direction, mass m2, velocity in this direction, mass m3, velocity v3 in this direction. But for the entire system, momentum remains conserved. No changing in the entire system of the momentum. So condition is what? If there is no external force act on this body, my body is also constant. It has momentum conserved. But condition is what? No any other force act on my body. That is what? External. Internal forces are acting in the body that have different advantages. But there is no any external force act on the body. So in a system, लाइफ है, मेरा लाइफ है, बाहर रखो फोन. In a system of a body, or in a system in which there are many particles have different momentum, but total momentum remains conserved. If there is no any external force, act. So here force external is basically zero. No any force is acting on this system of the body. So for the many bodies, you can write for the many particle, you can write M1 V1 plus M2 V2 plus M3 V3 Mn Vn, और फिर these are velocities. So this remains what? Conserved. You can see. You can also say P1 plus P2 plus P3 plus Pn. All the sum of system is conserved. Sum is what? Zero or conserved. In this case, again I am writing force external, you consider zero. So we can write F is equal to dP upon dt. Now this is zero. So dP upon dt is also zero. Now you can write dP is zero. Yani P is what? Momentum is what? Constant or conserved. Similarly, if you write P, it is dP upon dt, keeping mass constant, is equal to zero. So velocity also becomes zero. Velocity also remains what? Constant or conserved. So I am telling you, not momentum is conserved. In the system, entire velocity also remains what? Zero or constant or conserved. Now we discuss here about the two systems, two applications in your life, in our life. So I am not telling you this is the problem, this is the question, this is the calculation. We are studying not difficult things. Physics is, I think, very simple and very applicable in the all system of the nature. So first application is, suppose collision of a truck and a car. Second application, we discuss about recoil of gun. So today I start from the collision of the truck and car, maybe bike, maybe other vehicles, maybe another two bodies doing the collision. There is a truck. This has mass m1, and there is a car. This has mass m2. This has velocity initial u1. This has initial velocity u2, and there suppose u1 is greater than the u2. This is the system I am telling you before collision. Before collision. Here the truck and the car may undergo collision. Both are collides. This mass is m1, this mass is m2, and there is E1 E2 during the system of collision. During collision of the two bodies. Again, there is a truck. Big vehicle. There is a more speed of car, you can say. M1 has velocity v1, M2 has velocity v2. So here velocity of car is greater than velocity of truck after the collision. This is the system of after collision of the two bodies in the system. So, see the system of the collision between the truck and the car. What happens here? There is force acted by the truck on the car and car on the truck. So, force on the car by the truck is here. Force applied to the on the car by the truck. Again, car apply force on the truck. Force on the truck by the car. PC. So direction is different. This you can see. I am writing here that force on truck by the car is equal, but opposite force on the car by the truck. You can also write minus sign indicate that direction is different. Force on the truck by the car. Here force on the car by the truck. To correlate the forces, sometimes there is a sprint while the collision of the truck and the car, like that. So that time you can also add force on truck by the car for the small time interval delta t is equal to minus of force of the on the car by the truck of the small time. So this indicates what? Impulse or impulsive force. There is also impulse or impulsive force. So what happens during the collision of the two bodies? Momentum changes. There is initial momentum, mass into velocity, mass into velocity. There is final momentum of the body changes. So momentum change of impulse change. Sorry, impulse is here. Impulse is what? Change in momentum. Impulse, you know, is equal to change in momentum or linear momentum. So momentum of truck changes, momentum of car changes. So how much is momentum of truck? How much is the momentum of truck? Car, I will write here. So there is truck, there is truck. So I am writing here. This is momentum of truck. This is the momentum of car. So I am writing here momentum of truck is equal to minus of momentum of the कार. ठीक है, like this I am writing here. Same thing for the truck. Final velocity m1 v1 minus m2 m1 u1. Again I am writing here minus of m2 v2 minus m1 m2 u2. For the truck, final momentum minus initial. For the car, final momentum minus initial. So final minus initial, final minus initial, there is negative sign written here. I am writing again this equation m1 v1 minus m1 u1 is equal to minus of m2 v2 minus m2 u2. again. You can write here, this becomes what? Plus. This becomes, after multiplication, minus m2 v2 plus m2 u2. Again I am writing m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Again reverse it, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the final equation. You will one know, this is momentum before collision, this is momentum after collision. So you found it that momentum before collision, momentum after collision, there is no change, there is no disturbance. It means before and after collision, momentum is constant. This is what proved here. One other example also like to apply here, that is recoiling of the gun. Second part, recoil of the gun. There is a gun. There is a bullet here, and this gun has mass capital M. This bullet has mass small m. Initially, there is no velocity of the bullet, there is no velocity of the gun. So initially what happens? Initially when bullet is at rest, total momentum, sum of momentum is what? 0. There is gunpowder. This gunpowder, it is what? Not external. There is no any external force. I am not applying force here. Here external force is not applied. External force is what? Here 0. So gunpowder is applying what? It applies internal force. Apply. Therefore, this bullet come out. This bullet come out and it gain velocity. Now when bullet go out, then gun, what happens? Recoil backside. In the firing of the gun, this system work. Now what happens here? After bullet fired, what happens here? When bullet is fired, after firing of bullet, what happens? Mass and velocity, mass and velocity of this recoiling gun is this, and this is equal to minus of mass into velocity of the bullet. So you can write here that velocity of recoil is minus of mv upon total mass of the gun, and negative sign indicate that recoil takes in this direction, bullet go in the forward direction. So this is indicating what direction. Force also indicate direction which act in the which direction. So impulse is force into time. It can be also written in the showing what directions. Now we are going to application. Again, you can say your brain think like this. Think like this. I am telling here a car of mass 1000 kg is in motion five meter per second. And its engine apply 1000 Newton force, but due to friction of the road, (500 Newton) force is applied on it. You can find its velocity at 10 seconds of motion. I am telling you, read the questions 1 times, 2 times, 3 times. Then you can go to the what is given to you, what is have to calculate, all these right. So you are doing data analysis, analyze the data given, then write the formula which can be used, and thereafter get the actual result. So I am thinking that how much is the net force acting in here? Total force is acting in forward direction, applied force minus opposite force, opposite direction force. This is by the engine 100 Newton, opposite by the friction 500 Newton. Total force is here actually 500 Newton. And mass of the car is also given. So you can calculate force upon mass. There is 500,000. This gives the acceleration 0.5 meter per second square. Now you apply to find the velocity equation v is equal to u plus at. You consider at 0, acceleration is here 0.5, time is 10 seconds. So this is 1 meter per second is the velocity of the car. Again, you can think you can apply second thing. A scooterist having mass with a scooter with vehicle (300 kg), but you see that a boy is present on the road when the velocity is 36 km per hour he applied brake to deaccelerate to prevent collision. Then find the force used if the scooter in the 4 second. So again, I suggest you read the questions 1 times, 2 times, 3 times. Write the data given. Also write what to calculate, what to find out. Then write the equation, formulas used for the calculation. So I have to calculate the force applied by the brake. You are given basically acceleration. This is velocity upon time, and velocity is given 36 km per hour. Everyone know 36 into 5 by 18. This is 10 meter per second in the SI unit. So acceleration is velocity upon time. Velocity is 10 and time is here 4. So this is 2.5 second meter per second square is deacceleration by the brake. So force you know, F is equal to mass into acceleration. Mass is given by 300 kg. Acceleration is 2.5. So this is what your answer. Third application I like to discuss you, which is used in your general life, in the every life. So third application is here. A metal block is placed on frictionless surface and a jet release water at the rate of 2 kilogram per second. Then what will be the acceleration of the metal block if its mass is 2 kg. So I told you that in the river flow, mass of the water changes. From the tank, mass of the water changes. When use the jet, that is also called in the null, I getting water to hand wash, to the drinking, to the food making process. So there is application of what? Mass change, basically. I am drawing a diagram. This is a metal block and a jet. A jet is releasing water here. So water go to in this place, in this place, in this place, and its mass is what? This mass is 2 kg. And rate of water flow, यानी dm upon dt, this is what? 2 kilogram per second. That is the rate of the water flow. Again, you know, F is equal to dp upon dt, dp upon dt. So generally, what it is here? This is dmv upon dt. Here mass is constant, velocity is constant, mass is changing here. So in general, this velocity initially was in the rest, and its final velocity is also given in diagram 1 meter per second. I make diagram for you that is given in the question, initial and final velocity here. So in this case, when there is force is equal to velocity constant dm upon dt, then this is equal to 1 into 2 rate of mass released of the water is 2. This becomes force is equal to 2 Newton. And for the acceleration is force upon mass. Your force is how much? 2 Newton. Mass is 2 kg. Then acceleration of the body is 1 meter per second square. So this is the answer. So all this discussed by the application of the Newton's law of motion. In the next class, also we practice the problems of H.C. Verma, and since we have to finish the course in the limited time, so I increase the time class to class, and I request you everyone join my online class. You can also ask the problem on the site, by the message, by the calling of my number. My number is here 98-100-350-93. This is my contact number. You can talk me to discuss the problem. I also place or manage the time for the discussion of the problems. Thank you very much.